if you don't have a good understanding of the weed that you're targeting, you're not going to be able to keep it under those action thresholds.
Welcome to the Crop Science Podcast. I'm your host, Brian Ernell. Today, I'm honored to have Dr. Liberty Galvin with us. Liberty is actually new on campus here at Oklahoma State, where I'm stationed at in Oklahoma, Stillwater. Liberty is our relatively new assistant professor of extension weed science and precision weed management. We're really excited to get her down into Oklahoma, back home, as a matter of fact, or back into the state. Liberty, share with our listeners a little bit about your history, where you came from, your background, both, just growing up, where you did school, and really why you've wound back up with that orange logo back on your chest.
Thank you, Brian, for the invitation to the podcast. First of all, it is great to be back in the state of Oklahoma. Both sides of my family actually are from Oklahoma, and I grew up in Bartlesville, really close to the Kansas border. We did not grow up on a farm, but my mother's side of the family had a cow-calf operation in central Oklahoma. And so I think my love of agriculture really started as a kid. I love being outside. I love being out on the range and just seeing those vast open spaces. And I think my love of the outdoors is what drove me to come to Oklahoma State for my undergrad. So I got a bachelor's in environmental science, and I have 2 minor degrees. I think around my third year, I was like, I really enjoy environmental science, but I think if I want to make an impact, it's through agriculture. So during my undergrad, I pursued a double minor in soil science and agronomy. And through some study abroad activities that I did at Oklahoma State, I found myself at the University of California, Davis, doing a master's in international agricultural development. While I was there, I had a graduate research position in the weed science program with Dr. Bradley Hansen at UC Davis, working in alfalfa. And trying to identify cold intolerance in Roundup Ready alfalfa. I really like doing international ag, but I loved doing weed science. And so after I finished my master's degree, I pursued a PhD in horticulture and agronomy with Professor Kasim Al-Khatib. And his lab focuses on weeds in rice. So I actually came from the prairie studying small grains out to California in a very, very different small grain environment. But his program is very applied. We worked with a lot of industry partners. We had a very successful herbicide screening program. We participated in a lot of field days and grower meetings. And so the position that I have now at Oklahoma State is actually pretty similar to, ideally, I would love to mimic Professor Al-Khatib's lab for my own lab. I am now the extension weed scientist and precision weed management. That is my full title. It's a pretty long title.
Yeah,
and depending on
the long titles.
Yeah, and depending on who I talk to, I only tell them one part or the other. It's like you don't need to know the whole bit. But my emphasis here at Oklahoma State is small grains. I'm a member of the wheat improvement team, and the joke is that rice and wheat are pretty much the same, and one is flooded and one is not. And it's been pretty funny coming back to Oklahoma because that is not true.
No.
I will say it is much easier to walk through a wheat field than a flooded rice field. So I'm pleased to be back in the state, no longer working in rice, now working in wheat. That's my main focus. And I'm also really excited. I have another colleague, Dr. Swati Shrestha. My appointment is 85% extension, 15% research, and her appointment is 70% research, 30% teaching. And she is oh my gosh, and now I'm blanking on her title. She is weed research, um, ecophysiology, I think is actually her title, her specialty. Um, Dr. Shrestha started, I think, 2 months before I did. And we have actually met each other in the past at weed science meetings. And so I was very thankful to um, find another young colleague, another weed science colleague who was equally excited about collaborating with me. And we've already submitted a couple of grants. We're working on some pretty cool stuff that we have in the works. Yeah, so exciting to be back, exciting to have a fresh colleague to work with, and to see all of you all.
Explore the future of agriculture with KWS, a global leader in innovation and sustainable farming practices. Uncover the exceptional qualities of our hybrid rye, cultivating a legacy for a greener tomorrow. Visit kws.com/US for more information and for dealer locations. KWS, seeding the future since 1856.
Well, it's really awesome, and I came in at a time, and this is a long time ago now, but I came in at a time where there was a group of hires, right? And so,
Yeah.
a lot of times universities don't get to do that. They don't get to hire a group,
Hmm.
and I can't imagine coming in solo, like being the young one on and having already established, but the value of having that person to bounce ideas off of, to walk through life as it is, walk through the
Hmm.
academic life as a new assistant prof. Man, there's a ton of value in that, and even more, I'm really excited for your opportunity because you guys are. It's one thing to be brought in with somebody else at a completely different area that you just kind of
Hmm.
get to work together, but you and Swati have an opportunity to really build off of each other's programs
Yeah.
in a way that I haven't seen too often. Right? There's been some programs come in that are cluster hires, but I think there's some really great opportunity with you and Swati working together.
Yeah, I agree. And yeah, again, just so thankful to have her. And it's a really, it's also a really interesting differences between my professors, who a lot of them are, well, not all of them, but a good chunk of the folks I worked with at UC Davis were sort of very late career.
Hmm.
And the way that our late career colleagues behave compared to the mid career colleagues compared to Dr. Shrestha and I are very different. And so, there cultural similarities, and we're both women, and that's really exciting. And we have a lot of the same colleagues because she
Hmm.
actually worked in rice.
Yeah.
And so she and I have a lot of the same folks that we're like, oh, we should work with that person. We've engaged Dr. Muthu down at Texas A&M.
Hmm.
Dr. Shrestha worked with him for a year before she did her PhD, and he works in rice, and so we would see him all the time. So it's not only are we new together, we have a very similar network. So we've already kind of, I think we've had a much easier time lifting off, compared to, like you say, like a solo hire would. Yeah, yeah.
So, in some of the topics that you have listed here, it lists the importance of, and we talked about another one we'll bring in, but you've talked about the importance of biology and ecology knowledge when it comes to applied weed management. So, kind of elaborate on some of what you're looking at when it comes to biology and ecology.
Sure. My background is in weed science is a lot more biology, ecology focused. And I think now Dr. Shrestha is really the one who is answering those deeper population genetics questions, gene flow questions. But for me, as an applied weed scientist, I really see opportunities with herbicide applications and with all of our weed management applications. If you don't have a good understanding of the weed that you're targeting, you're not going to be able to keep it under those action thresholds.
Hmm.
So for example, during my PhD, I worked with weedy rice. Weedy rice is exactly what it sounds like. It is a weedy species of its cultivated relatives, which we like to consume. Now, if they're both rice, how do you know when to spray? You can't really scout for it because it looks all the same. And so what I was really looking at is what environmental conditions were conducive to the growth of this weed. And can we use those conditions and monitor those conditions to time our application strategies? So I actually think the Mesonet has some really cool apps. I think they have an alfalfa weevil app, which is the one I really like to use for demonstration. And this is pretty similar to what I'm talking about. They're
Hmm.
weeds, just like insects, just like viruses and pathogens, they develop at a very predictable rate, depending on the temperature, depending on the moisture, whatever that particular plant needs, right? So for weedy rice, it was temperature and moisture. They didn't really need oxygen. They didn't really need nitrogen. They didn't really need solar radiation. So when we can kind of, excuse me, narrow down on those factors, what are the thresholds for those factors that then push these weeds to develop or push your alfalfa weevil to develop from the larval to the adult stage? Pretty similar stuff. And so that's something in the longer term that I really want to work on is, we have problematic weeds in the field, and a lot of growers tell me that they think they have resistance of one thing or another. But then I hear from neighbors who say, well, my neighbor sprayed their mare's tail when it was 3 feet tall, and now I have mare's tail seed blowing into my field. It's like, well, maybe it was resistant. I don't poo-poo on somebody when they
Yeah,
tell me they
no.
think resistance, right? But I do wonder if they're applying at the correct time. And I think there's sort of a general perception among the population that ag chemical companies will keep up with the rate of resistance. They'll put up new products. Like, we don't need to worry about the longevity of the products that we have because the chemical companies will keep up. And that is not the case, especially if you work in a lower value crop. So wheat doesn't have the market price that cotton, soybeans, peanuts do, right? So the rate of new product creation is going to be just a little bit slower for wheat crops than it
just
is for
just
these other
just a
crops.
little bit.
A little slower. So,
Yeah.
so another reason to like do these timing of application studies is so that we have product longevity, you know. Um,
And so I'm excited for you to be here. And I know that you've just through the vine. I know that you're kind of getting into another project long before you came. In fact, I was considered young at the time when we started this. We got into some nitrogen timing by herbicide timing in wheat and Italian ryegrass. In fact, that was Robert Calhoun's thesis.
oh wow.
So Robert, you probably have seen Robert run around, but that was his thesis with Joe Armstrong, who's
Okay.
now off in Indiana again. I just talked to him the other
Yeah.
day, but it's fascinating. We never got anywhere because the funny story was Joe was new too, went on ground that was supposed to be littered with Italian ryegrass. And so, he plants, he doesn't sow his own seed. He just goes out there because people said, this is just loaded. Don't worry about it.
Sure.
Well, there was no ryegrass in any of the studies.
Oh.
And so we had a beautiful nitrogen timing by herbicide, but we didn't
Mm.
have rye. So the check still didn't have ryegrass. But it's fascinating to look, the integration of stuff. We start talking about the integration of herbicide timing, now the integration of
Mhm.
fertilizer timing as we look.
Mhm.
I'm trying to delay nitrogen in crops, which will actually slow the crop growth. I want a smaller wheat crop. Well, that goes in against competitive nature of let's canopy
Yeah.
over so that we do that.
Yeah.
But it may open it up so that herbicide, has more direct contact if we have. And then what's the nature if the soil is deficient in nitrogen and the weeds
Yeah.
aren't aggressively growing and the wheat's not. And so there's been a lot of stuff I'd love to dig in, and we're digging into tillage. You know, we
Yeah. My
we got
gosh.
25-year-old no-till fields that I think honestly, due to nutrient stratification, due to other issues, and due to weed banks, probably need a inversion tillage once And what does that mean?
Which is so
And
risky. Yeah.
huh?
Which is so risky.
Well,
You don't know
yeah.
what you're going to find
But hopefully,
underneath all
whatever you
that.
find, if it's been no-till for 25 years, hopefully what you find isn't chemically
Nothing.
resistant to the degree.
True. Yeah. Yes.
Hoping to dig into some of this stuff. I haven't got to talk to you yet. Talked to Todd the other day, but we know some farmers who are looking at this, so we're wanting to
Yeah.
do some soil sampling and maybe take some weed bank analysis before and
Yeah.
after tillage. And then I personally have bought for my research program 3 sweep plows because windmill tumblegrass has been
Yeah.
such a challenge. Talk a little bit about bringing in all of the aspects into your research program, because I'll just put, you've got a few opportunities, right? You can go a lot of ways. So what's
Yeah.
kind of the stuff that you and Swati are working with as far as programmatically that you're at least kind of seeing the trends you're going through?
Well, a grant that Swati and I already have submitted is first and foremost, we don't have a good, um, we don't have a good snapshot of all the problematic weeds across the state of Oklahoma, you know, and where are they?
Mm-hmm.
Do we only have windmill tumblegrass in no-till fields?
Mm-hmm.
Do we only have ryegrass in wheat fields, or do we also have it in canola because it's also a small grain? You
Mm-hmm.
know, the the first kind of big thing that she and I are doing is this big scouting effort, and we're trying to use that as an impetus to reinvigorate our screening program. Because if you have herbicide resistance in your field, you need to know.
Mm-hmm.
And quite frankly, she and I want to know because it's very exciting. You know?
We're
From
glad
a
somebody can be
nerdy,
excited about resistant weeds, right?
yeah, from a
Somebody should
nerdy
be excited.
science, yeah, we're the ones, maybe
Yeah.
the only ones, but we're the ones. um, and then, you know, from my PhD, our screening program fed a ton of graduate research programs. Um, so that is sort of one big jump off platform that we are trying to create for ourselves through 2024. Um, we're doing the scouting, reinvigorating the screening program, and really, and not just scouting, but we're going out and meeting people. I'm pretty excited about the scouting because I do want to ask people like, well, why do you think that you have
Yeah.
resistant ryegrass?
Mm-hmm.
Is it because it doesn't come up until after you've planted? Because it's a cold season annual, Um, so there's all those different, pretty foundational questions.
Yeah.
But then the next level, I think for me as an applied person, is let's look at all the different tools. And I really, really want to focus on no-till. Just a little side story. There's that new movie that just came out, Common Grounds.
Oh yeah.
I have not seen it, but a girlfriend of mine messaged me the other day and she was like, "Hey, tell me the real. She's like, you as a PhD in ag, like tell me." And she was like, "But don't you think we should be doing no-till farming and cover cropping and precision irrigation?" And I was like, "Girl, we do that. You can
Yeah.
come on down to Oklahoma." She's actually from the West Coast originally, and she lives here in Oklahoma. And I was like, you want to see a really well done soil conservation focused field? I'll show you. It's not that far from our houses,
Yeah.
and so I think on a national scale, we as South Central Great Plains folks who are doing a lot of soil conservation stuff, we
Mm-hmm.
don't get the credit that we deserve. And I think a big project for me is looking at those no-till systems. How can we maintain our soil conservation efforts
Mm-hmm.
that really have been going on since the Dust Bowl?
Yeah.
It's not new stuff.
Yeah.
But just like you're talking about with windmill tumblegrass, we have herbicide resistant weeds because these no-till fields are heavily dependent on herbicides.
Mm-hmm.
So, and the whole point of no-till is that we've deleted the mechanical option. Okay, so then what are our options left? Right. And something that I really want to work on, and I actually have an undergrad, gosh, I'm probably going to get this wrong, but his undergraduate major is natural resource ecology management with an emphasis in range, but he's a wildland firefighter.
Rangeland ecology and rangeland.
Rangeland ecology. Thank you. Yeah. I was like,
I
it's
know a few
under
of them.
one of
Yeah.
the umbrellas. Yeah.
Yep.
Um, but he actually has field experience
Hmm.
in wildland firefighting. And I know that Dr. Misha Manicherry, now Misha Bird, who
Hmm.
was in this position before me, had kind of started to look into fire. And I have a lot of colleagues. Uh, I picked Dr. Jason Warren's brain the other day. And fire seems to be like a great opportunity.
Hmm.
We don't necessarily have to disturb the soil. If you have a no-till operation and you have all that stubble on the soil surface, that's
Hmm.
probably enough fuel. But then the question is, we're talking about seed bank management. We want to cook the seed bank a little bit. But
Hmm.
with weeds, the ones that are going to give you the most problems are the ones that are in the top, really like 2 or 3 centimeters.
Hmm.
Weeds love the ideal conditions for germinating. And if we can somehow burn those in the top few centimeters, I think we could actually maintain our current no-till efforts. But obviously, there's a lot of questions.
A lot of questions. I'll add the fun ad. Oklahoma has a long history of supporting prescribed burning. In fact, I just dug up the number. Annually, we burn about 2.5 to 3 million acres of
Wow.
rangeland and pasture in a prescribed management, and that fluxes from year to year depending on our fuel availability, like you mentioned. Historically, we had historically, fire has been used in winter wheat production, but it's been used along with tillage, so they would burn the
Hmm.
till. And so I think that some of the things you're interested in has a lot of questions that we don't know. Is burning within a no-till? So we know burning
Hmm.
within tillage, we know burning within range,
Hmm.
but burning within no-till is a little bit different scenario because of the potential for erosion. But again,
Right.
if we're in no-till, hopefully that seed bank itself isn't. And so this is my question: if I'm in no-till and
Hmm.
I have a weed go to maturity and drop its seed, is that seed making it half an inch down, or is it staying at near surface?
I mean, it's definitely going to stay on the surface. It kind of depends on what you do after that.
Hmm.
So the timing, back to that timing of application. Do you burn the stubble right after you harvest so that you cook all those seeds on the soil
Hmm.
surface? Or do you need to wait and use fire as kind of like a pre-plant management
Yep.
strategy? You know, but then Dr. Warren and I were kind of talking about cover crops.
Hmm.
So if you harvest some crop in the spring and then you cover crop for the summer, I mean, the hope is that your cover crop has deep roots. And so if you use fire as a pre-plant for, let's say, wheat,
Yeah.
and you burn that cover crop, is that fire going to kind of follow down the root
Down the root. Yeah.
profile?
Yeah.
Uh, is it hot enough?
Oh
So
yeah.
I think there's like that timing of application thing is also really, really important. And what the grower wants to do. Um, we
Yeah.
have
And
wheat guys
even with
that
the
only grow
cover,
wheat.
can you desiccate it in enough time to get it to dry enough
Yeah.
to burn?
Yeah. If we get a late summer rain, we're not going to be able to set it on fire because it'll be wet. you know.
We
So then
used
do we
might
have
have
to
been
mow it
Jason.
down?
Yeah. Oh yeah.
You know.
Jason, was it Jason or Josh, Dr. Lofton or Dr. Warren, used fire ahead of canola looking at seed bank prepping in front of canola. And Bill, I'm trying to remember the graduate's name, um, uh, Bill Jones, did his
Hmm.
master's on tillage versus no-till versus fire to prepare for the canola seed bank, since that is such a challenging seed to plant, and also its influence on weeds.
Yeah. Josh Lofton did that.
Yep.
Uh, and I know he's been doing some canola stuff. Uh, and quite frankly, as the new small grains person, I have been meaning to get over there and be like, "Hey, Josh, tell me the lowdown here. Let's
Yeah.
team up on this," because he's the agronomy guy, and
Hmm.
in my opinion, agronomists are the jack of all trades. And so I think, and I just really like Josh. He's a great scientist. So. Um, he was one of the people I was going to talk to and send my grad student over to talk to because he has thought about fire as a pre-plant.
Hmm.
Yeah. Bed prep. I'm writing this
So
down. I'm taking notes.
that's awesome. So, and one of the last things I want to bring up and some of the stuff that you mentioned was, talking about phenological development, the
Yeah.
germination and emergence, a little bit with the thermal time. So I think that's
Yeah.
really interesting if we look at our seed bank population and thermal time and emergence. So tell us a little bit about what you've done and kind of how you see that fitting in the Southern Plains.
Yeah. This really, thermal time is kind of the fancy science terminology for growing degree days. I think a lot of people are really familiar with growing degree days for crops. Um, and kind of using that alfalfa weevil example from the mesonet, that is
Hmm.
also a growing degree day calendar. Uh, and it's very difficult to use those growing degree day models for weeds because um, they're so different, right? And this kind of gets into what Dr. Shrestha has more experience in with population dynamics. The ryegrass that you have in your wheat field that you've had in your wheat field for years might be really different than the ryegrass that they have like in an orchard, for example. Um, and so this growing degree day stuff, I think, is very helpful for the timing of application, but it's more helpful for scouting. So if my ryegrass looks really, really similar to, or the bromus species, they look so similar to wheat when they come up.
I hate it.
I took my students out to scout for bromus the other day in our field, and they were like, "How do we find it?" It's like, we're just going to stand here until we see one.
You'll see it. Don't worry.
You'll see it. There's not very many of them, but you'll see it. They have little red nodes at the base of their
Yeah.
growing points. But can we use these models and apply them to the weeds that we find from our scouting activities
Hmm.
and say, okay, bromus from Beaver County develops in 5,000 growing degree days, but bromus from Bixby, where we get a little bit more rain, where it might be a
Hmm.
whisper cooler, maybe. Um, bromus from Bixby matures in 3,000 growing degree days. So, not wildly different
Yeah.
from the crop growing degree days, but weeds don't want to behave in predictable manners. And there's
Yeah.
so many different, um, not necessarily, well, kind of like subspecies that are heavily influenced by the environment. So can we create some thermal time models or some growing degree day models to help us time our scouting events, first of all?
Hmm.
And some people don't even have time to scout before they need to spray, especially if you depend on a co-op for spraying. So you could even use these models to say like, okay, well, based on how warm it's been and based on this mesonet calendar, we're going to hit 5,000 growing degree day units in uh, next week. And I want to get ahead of, I don't want to wait until my bromus is 3 feet tall. So I'm going to go ahead and call the co-op and ask them to come spray in 2 weeks. Something to give growers a little bit more information. Um, but those are emergence models.
Yep.
And in terms of phenology, they have to germinate first. So it's
Mm.
not just an emergence model, it's a germination model that is then coupled with an emergence model. And for my PhD dissertation research, I worked with 5 different accessions. So they were all genetically different from each other. And I tested temperatures from 10 degrees Celsius to 40 degrees Celsius in 5
Mm.
degree units. That experiment to get 3 good replications took me 3 years, right? So I think people look at these growing degree day models and they're like, these are cool, these are great, or they're like, this has very low accuracy. Why do people put
Hmm.
these together? Well, it could easily take a decade to make one of these models.
So I'm going to go sideways just because I've
Please.
always wanted at least so dumb it down to a soil scientist here as we look at it, because I look at the weed species that we deal with, and I can name 80 that do this, but we have multiple flushes, right? So
Yep.
it's not like we're even doing anything to the soil to initiate a flush, but it's with a rain or this. How is it with the weed that with the proper conditions, it all doesn't just flush at once? And I'm thinking, I don't know, brome does, it seems like, vetch does it. It's like all these different flushes, which is frustrating to say the least on timing your
Yes.
herbicide.
So my immediate assumption is that has to do with the burial depth. I
Mm,
guess if you're working in no-till, there is not really a burial depth factor, but there could be a cover, like a stubble cover factor. And the soil has incredible temperature buffering capacity, right? And so maybe so for our winter annuals, right, it's going to get cooler on the soil surface before it gets cooler at a 1 inch depth. And so the temperature gradient through the soil could cause multiple flushes. But similarly with rainfall,
hmm
if we only get a 1/2 inch rain, it's only going to provide moisture to those seeds sitting on the soil surface. Or if we get a 2 inch rain.
hmm
Um, but without really understanding, without talking about a specific weed species in a specific system, it's hard to say. But those are kind of my immediate assumptions. Like it has to do with where they sit in the soil profile.
Well, I figured. I mean, it's almost like you said. The agronomist's best friend is an answer, which is it depends,
It
Brian.
depends. Yeah.
It depends.
It's time for our famous three.
We're out of time. I think we can go on like this for a
Sure.
while, but I want to go
Yeah.
through the three questions.
Okay.
First, as you look at work resources, what's a go-to work resource you have when it comes to work questions?
I have to tell you, Brian, I heavily depend on my colleagues like you for questions. I just started in October, and so I'm still trying to figure out regionally who my go-to people are. I know that Josh Bouchong is a great um, wheat resource, but he is so stinking busy um, that I try to be very explicit and direct with my questions to him to not waste his time. But I know where your office is. You know what I'm saying? So
Well,
I've been
I
looking
only started in
internally.
May. Yeah, I only started back in May, but that was in 2008, and I still
Yeah.
go to those who have been around, or not even been around, just folks like you. You're going to find me in your office a lot too, Liberty. So don't
Yeah.
worry
That's
about that.
fair.
It's about the resources we have nearest. Uh, so the next question is, what's your favorite leisure activity? What do you do in your free time? Because I know you have a ton.
Oh yeah, so much free time. Um, I grew up playing sports.
hmm
And when I was at Oklahoma State, I feel like this is very telling and I can't decide if I should tell people this, but I started playing ultimate frisbee at Oklahoma
Yeah.
State. And that actually carried through adulthood.
hmm
Every place that I've moved to, I've found community in the ultimate frisbee folks, and I actually play on a women's club ultimate frisbee team here in Tulsa.
That's awesome. I
Yeah,
love it.
yeah,
I love it. There for a while. I did beer league softball for a very long time. I mean, summer league softball for a very long time. I guess I should
yeah.
say.
I
Um,
like the community aspect of sports,
absolutely.
of organized sports. Yeah.
So, do you have any place people can go to find more about what you're doing at Oklahoma State?
Yes, but I need to like get after it and update it. So right now, LinkedIn is the best place to find me, find what I'm getting into, and I've reposted a couple of things from my colleagues that I think are really, really important.
hmm
But I need to start a Facebook page. At the Rural Renewal Symposium late last fall, we found out that 77% of our rural population get their news and information from Facebook.
Yes.
Um, so for my rural stakeholders, I need to start a Facebook. For my professional academic colleagues, I need to start a Twitter. Uh, and then my expert page, which I have not filled out, but that is on the to-do list. So find me on LinkedIn right now, but then I will be aggressively posting all of these other things on my LinkedIn through that platform.
Fantastic. Well, Dr. Galvin, thank you so much for spending the time with us today on the podcast. And of course, subscribers or those listening, folks, subscribe to the channel. That's the one way to keep us going on this. And if you like it and you subscribe, you'll get our notifications. Share this video to others if you've learned something today. And also, feel free to leave us a comment and suggest any new guests you might have.
Thank you so much.
Thanks, Liberty.